Going to take a look here at project number 8. In this project, we have a table that has 3 different outputs. So an output for hydropower, an output for wind power, and an output for solar power. I'm going to look at an example that uses some of this data, but not all, so you still have opportunity to complete the project on your own. I just want to give you an example of how to get this started with a 3 output situation. So I've started a Desmos graph. I'm going to slide it over here onto the screen. And in this one, I have the usual X and Y columns. I have not entered. Let me minimize this or resize this real quick so we can see what parts I've entered. One of the things to keep in mind is that looking at my independent variable, I have chosen to count since 2005. And so I've used 8 minus 5 is 3 for the first output. 2009 minus 2005 is 4 for the second input. And I've only gone up to 6. So I only have data for the first 4 of these columns of data in this one. So I don't have the full data set. I have not typed these other ones in just to make sure that the example I have is not the full and complete example. So it gives you plenty of opportunity to complete the project and analyze it on your own here. Okay. We always need to choose a starting year when I have years. I don't have to tell you in the description of the problem to choose a starting year. You need to choose a starting year. And so some people have chosen 2000 as a starting year because that's a convenient year to subtract from. So if you had chosen 2000 and done 8, 9, and 10 here, that would have been perfectly fine. If you had chosen 2008 as your starting year and done 0, 1, 2, etc., perfectly fine. But you can't choose year 0 of the AD calendar and then count up to 2008. That's just so far away that it's going to make the values in your equation extremely large, and you do not want that. So make sure that you have a starting year that is close to the data set. Sometimes we're told exactly what it should be. Other times we have freedom to choose for ourselves, and that's the case here. So I have chosen to count from 2005. All right. Now, I'm going to make a note of that real quick and put that on top. So we're going to let T be years since 2005. It's polite to just tell me what you pick for your starting year so that I know and don't have to try to figure it out for myself. So I'm going to use that as my starting year. Now, since there are 3 different output columns, I have the first output column, so the hydropower, in the first column down here. So 885, 915, 945, 970, etc. Then you can make the other 2 in the same table if you like, because they have the same independent variable. You can use the same table. That's kind of fun. And so you would just put in a new one, and I can put in a third one over here. So I've got X, Y, I picked Z. If you run out of letters, you could pick like S, 1, and then just keep going from there. Okay, so instead of doing all 3 right now, I'm just going to do 2. So it looks like I skipped wind power. You're going to do wind power probably as your second column of dependent variables, and then your solar power, which is what I have here, is going to be your last. So my project is only going to have part of the data to give you some more flexibility and make sure that you have the ability to answer yourself instead of just looking at my answers here. So I skipped wind power. You're going to have that in there. And then I have some of my solar power data. So the 16, 23, 40, and 70 are showing up here. All right. So I'm going to make this one big now that I have the data that I want in my file here. Only got a little bit of it. That's okay. All right. So my table has 1 independent variable and then 2 different dependents. Yours will have 3 different dependents. And I need to get my regression equations. The first one is going to relate the variables X and Y. It's a linear regression, so I know that Y1 is going to be approximately MX1 plus B. And then that would be the equation. Let me zoom in on the data set. One of the nicest things about keeping everything in the same table with multiple dependent columns is when I zoom in on the data, I should be able to see the data for both sets in the window. If you make them as separate tables, which is another option, that's okay. But then you have to zoom in on one at a time, and you can't see both of your sets at the same time. So far that's what I can see. I've got one of my graphs up there. And then the next regression from this one down here is going to not use X and Y anymore. It's going to use X and Z. So I would use Z1 because that's the output variable, Z1, approximately MX1. I'm still using the same X plus B. And so now I have my second linear regression showing up down there at the bottom. Okay, and you would do 3, of course, because you're going to have 3 different pieces. Now, I might have said, let me minimize this again, to relabel the columns with different variables. That's fine, and I just want to show you what that would look like, to label them as T, H, W, and S. The reason for that is that when I have a lot of data like this, it's easy to forget which of these columns is which. And so I'm like, if I have a bunch of data graphs, I'm like, which dots are which? I don't know. And so we can do that. So I'm going to do that and show you how to change your regression lines. So T, instead of calling this X1, I'm going to call it T. Instead of calling this Y1, we're going to call it W for wind power. Instead of calling this Z1, I'm going to use S for solar power. Now, my regression equations went away because there's no longer an X1 or a Y1 to reference them. But X1, which was the independent variable's name, is now just T. And Y1, which was the dependent variable's name, is now just W, and my regression line's back. Same thing, X1, which was the independent variable, is now called T. And then Z1, which is the dependent variable for this one, is now called S. It is nice sometimes to relabel them with different variables that match the situation, because you don't need the subscripts. You need the subscripts with X and Y because X is the name of this axis, Y is the name of this axis. X and Y are reserved variables, but T and W and S are not. So I can just use them T as T, not having to do T1. I could do T1, that's fine, but I don't have to, and that kind of makes the equation look nice, I think. But it's up to you. So that's how I could rename these. And you would do the same thing with your other column for H for hydropower, and similarly could create your regressions. Okay, so just an added step in here. I was trying to show you that renaming those could be convenient, especially if you had a table that had multiple columns for dependent variables. Okay, breeze highs again, just want to look at my project questions. So we have done the first couple of things. We've made our table, we've labeled it, we've got our regression equations for each type of energy. So that took a couple lines to make all of those things happen. Then we're going to just make a note to describe the strength of the R values. Okay, and then we're going to make some other notes about conclusions. We need to be thorough and specific on these conclusions. And then which type is leading now, what will that ever change? Okay, all right. So the R values. Now, I did not use all of my data, so my R values are artificially inflated. They're super high because I have a lower number of data points. So I've got a 0.999, super high. It's a very strong model, and so is this one, 0.961. So if those were my R squared, my R values for both of those, I don't have a third one up there, but I would say that all of my models at this particular point are strong correlations. Yours might also all be strong correlations, or you might have a couple of strong correlations and a couple of moderate correlations. But you want to write that as a note. I'm not going to write that down right now, but write that as a note that your R squared values are in the 0.9 range, so they're strong correlations, or if they're in the 0.8 range, they're moderately strong correlations. So make sure your note expresses that. Now to get on to the other piece. What I noticed about with these two is I noticed that wind power is currently leading. It is higher, it has a higher output, so more of the global, I don't know if this is global, I have to go back and look at my situation here. This is power in gigawatts, just for renewable energy. I'm not sure if it's global or if it's, just in the country, but hydropower is currently producing more. Oh yeah, there it is, global indicators. So hydropower is currently producing more power. Okay, so let's make that big again. And I can zoom out on this, and it looks like from, again, my limited data set, yours will be different. But for my limited data set, it looks like hydropower is going to just keep on increasing and stay higher. So I would be writing this in my note if that was my conclusion. The hydropower is currently producing more than solar, and it's going to stay producing more than solar. I can see that a couple of different ways. I can see that they may have in the past solar increased more, but I'm not going to write that as my conclusion because that's way far extrapolation and that's not likely to come true. But I do think that hydropower is producing more energy and it's going to stay producing more energy would be a conclusion that would be acceptable from this current set of data. You need a different conclusion based on what your data looks like. The other thing that I could talk about would be slope. And I could say, I know that hydropower is growing fastest because its slope is the largest value. So I could be specific using my values. The slope for hydropower is 28.5 quadrillion BTUs, was it? I'm looking at the units over here. Gigawatts, actually, sorry, gigawatts of energy. And so that means that it is growing faster by 28.5 gigawatts per year than solar, which is only growing by 17.9 gigawatts per year. So I could write that as my note as well. So that gives you hopefully a few things that you can say. You can talk about where they're currently at, data points. You can talk about if they're going to cross, when they're going to cross. These ones don't cross, but when you put in more data points, they may. And so that can give you several things you can write about. Try to be as thorough. What's growing fastest, what the slope is, where they're going to cross, what year they're going to cross, and how many gigawatts of energy there will be when they cross.